minus y times minus 1. Okay? Now have a look at this, and have a look at this, and you'll see they are the same. Okay? So that means we have shown that, we have proven that the formula is correct for k plus 1, assuming it's true for k. So we use the formula for pk here, but that's the second step. That's the inductive step. Okay. Now we proved it was true for k is 0, therefore it's true for k is 1, and therefore it's true for k is 2, therefore it's true for k is 3, and so on and so on. In other words, this formula here is true for all t. Okay? And that's the end of the proof, because we've done our 2 steps. And then end of, it's a formal proof, and here's the end of proof marker that I was talking about a couple of sessions back. Actually, by the way, I got curious. I rather emphatically told you, I remember last time, a couple of sessions back, about the nature, the actual symbol for the end of proof marker, that generally speaking it's a vertical hollow rectangle, sort of a bit like this. But then I had some doubts, and this is afterwards, after yesterday's filming session. I started having some doubts, and I was saying, is that actually true? So I went to about 100 or so of my graduate level math texts, largely published by Springer. They have a famous series called GTM, Graduate Texts in Mathematics. I've got virtually all of them, I think. The whole series. There's about 250 or so in the series. I've got virtually all of them, except for one, I think, and a few perhaps the very latest. But, so I just went through a pile of about 100 of them, and I found that what I said yesterday was actually not, well, last time, was not strictly true. I mean, it was definitely true for some books. So there's still quite a range of end of proof markers or signs used, but I noticed the most popular one, I'd say about half of the cases, more recent decades, about half of the authors are using not a rectangle but a square, which is sort of easier, makes more sense. So they just have it often at the very right hand end of the last line of the proof. They'll have a little hollow square. Okay, so this actually probably looks to you a bit more like a rectangle than, well, depends on the camera angle. What I was asking you last time, put in the end of proof marker, but you may as well make it a square, because that's the majority use. Now I know some of the authors did not have an end of proof marker at all, and it's annoying, because then you don't know where the proof ends. So when you're looking at stuff for the first time, often it's not clear where the proof finishes and then commentary or new theory begins. It's not at all clear. So there's a real need to put an end of proof marker. So I recommend strongly that you do that. When you're writing up proofs and stuff, just put an end of proof marker. And I know about half, I guess, of these authors of these famous texts, GTM, Graduate Texts in Mathematics, they were using a hollow square. Okay? Alright, now just a little bit at the end here, before I finish off. You can actually use this formula now to make interesting calculations. If you have a scientific calculator, may help. So we now have a formula for the debt after T months of payment. Now assume that, let's say you take out a 30-year mortgage, monthly payments, so you make 360 payments, right? And at the end of your 360th payment, your total debt is zero, right? You've paid back the bank hugely more than you borrowed. So if the principal, say you borrow $100,000 and your interest rate is 5% annual, so your M will be 1 plus 0.05 divided by 12, right? That'll be your M factor. And you can actually calculate what Y has to be, your constant monthly payment over 30 years has to be to pay back the debt. Now you can calculate how much you actually pay out. It's hugely more than 100,000. So it's 537 roughly multiplied by 360. Look, I'll just do it. I haven't done it before. I'll just hold on. I'll calculate. I have a calculator stopwatch. So 537 times 360 equals, whoa, 193,000, and you borrowed 100,000. So you've paid back nearly double, right? So you can see how the banks get rich, right? And the higher the interest rate, the more money the banks make. As I was saying in the previous session about medieval Jews, they'd exploit people. It was called usury, charging interest. The world has learned that credit can be very useful, so long as the interest rate is not too hefty. But the Jews were charging 20, 30, 40% interest rates. So to gullible people who didn't understand the impact, they'd sign the contract, legally binding them to agree to the contract. And the contract had to have, like in the fine print, in failure to repay the debt, the debt will be taken out of the crop, usually farmers. And if that fails, then the lending company would take over the whole farm. So you'd have often the debt created, the contract made 1 year, following year can't be paid back. So these bankers, Jewish bankers, would take the crop, and then the following year they'd take the farm. Right? And it happened to happen so often that the Jews just made themselves hated. There's a whole philosophy on my attitude towards Jews. I really don't like what they've. I'm disgusted by what they've done in Palestine, and I really don't like what they've done to the American politics. They've virtually taken over. I'll give an essay video about my views on that. Anyway, it's of interest. And double meaning of the word. So if it's 40, that compounds furiously, right? Compound interest. Now you can use this in reverse if you're young. Now I'm old. Like I have a son-in-law, my Chinese wife's son, recently started working after getting a master's degree in computer science. And my advice to him was save young. Okay, so again, you can take advantage of the compound interest if you put money in a bank or whatever, and you're getting let's say 5% or whatever, 10% if it's the stock market interest payment to you, then compound interest can benefit you enormously. So if you save young and you put in you're saving regularly each year, and you start saving like 30, 40 years before you retire, then you can make a lot of money. You can be quite rich. So take advantage of compound interest. It's very, very useful. Okay. Now, so this is the end of this session, this board. and in fact this chapter. Okay. Now, in terms of the theory portion. So the next session will be on problem solving, where I will take some of the problems from the textbook. I'll solve in real time, pretty much. Maybe, I don't know, depends how many problems there are. I don't know, maybe a quarter, more or less, of the problems in the text, and leave you to do the rest. Just to give you a feel of how to apply the theory to actual problems. Okay, so I'll stop there.